Hello, welcome. Today let's try to solve another Leetcode problem, 983, minimum cost for tickets. So we are giving with 1 day, 7 day, and 30 day inside the cost array. So cost 0 means for the 1 day, and cost 7 day pass ticket, and cost 2 means 30 day pass ticket. Yeah, and inside the cost array, so this is the value of the ticket. So for the 1 day, it is $2, and for the 7 day, it is $7, and for the 30-day ticket, it means $15. And we are also having a days array. It means inside the array, this number means on day 1, we needed to travel. Yeah. So for example, in day 1, if we needed to buy a 1-day ticket, we will consume $2. So we will consume $2 here, and from day 2 to day 8 we can buy a weekly ticket, so we consume $7, so 2 plus 7 is 9, and on this 20 day, the last 20 day, we're gonna buy a 1-day ticket. It also consume $2, so in total we're gonna consume $11. Yeah, so this is basically similar to the coincidence 1 problems. So for the coincidence 1 problems, we are giving an amount of the money, and we are also giving a coins array. So inside the coin, there's many different kind of coins. So here, we are just giving a days, but there's no difference. Let me go to the whiteboard to explain my solution, and then go to the code editor to finish the coding. Yeah, so basically, we are giving a days array. So inside the days array, we need to calculate, for example, we need to calculate all the days consumed. Yeah, if we buy a 1-day ticket for each of the days, so inside it will be like how many of days inside? 1, 2, 3, 4, 5, and 7. So it will be 7 times 2. It is $14, but it is not the minimum. We need to calculate the minimum. That means we're gonna use other combinations like 7 and 15. So for the coincidence problems, we are also giving a coincidence. For example, we have the coins value of 1, 2, and 5. If we only use 1, we're gonna have more coins, but we try to use 2 and 5, we may need smaller coins, smaller number of coins to make them sum up to amount. Yeah, but for our days, it's also the same. So it's a DP problem. It's a 1D array DP problem. You can also understand it like unbounded backpack knapsack problems, but normally you don't. Normally you can also think of the method like that way. So here is also the same. We need to get the maximum of days because we are not considering of other days. For example, 365. We are not considering about those days because normally we didn't consume anything. We only need to consider the maximum of days. It is 20. You may consider, maybe we will only consider 1, 2, these 7 days. We will not consider other days. But for our calculation, we need to know we have the 7 days ticket. This 7 days doesn't mean you will spend 7 times to buy the ticket. It means the 7 days is continuous. And this 30 days is also the same. It means the 30 days continuous. You are not sure if you are buying this ticket before 30 days, that 30 days is also inside the days array or not, because this is just separate days. But for our calculation, we need to make it continuous. So how should we make it continuous? So our DP array, we just need to take the maximum of the days. So the value is 20. So for our DP array, we should to prepare a DP array. The length of it should be 21 because we're gonna use the index value as our days. So let me prepare an example. So for example, the index 1 here. So up here, it is the index. Yeah. So this index just means this index 1. It is just means day 1 and day 2. And here inside is our DP array. This value is calculated. Yeah. But for easy understanding, I'm gonna prepare another DP array just for my calculation, how can we get the result of the DP array? Basically, finally, we just need to return a DP minus 1. Yeah, because DP minus 1 is for the biggest days we consumed for this day 20. It just means the DP 20 just means we finished all those days. If the days is not inside, if our DP array, DP index, so for example, index 2 is not inside the days array, so what are we gonna do? Yeah, for example, day 1 is inside, we will choose a ticket, 1-day ticket. Yeah, so it will consume $2. So inside the DP array, from the beginning, we're gonna set every index each day to be 0. After that, we're gonna update the DP array. Yeah, so for the first index, it is 0 because 0 day, it means just nothing, just easy for our calculation. And for the first day, it means the first day, this index 1 is inside our days. It means we must consume something. So how much money we should consume? We should compare with 1-day ticket, 7-day ticket, and 30 days ticket. Yeah, so for us, this is only 1 day. So yeah, for us, we're gonna take the minimum of them. We're gonna choose this 2. So 2 will be the result. So I put a 2 here. But for the second day, index 2, this means it is not inside the days array. Normally, we don't need to specify anything. But for here, if we don't need to specify anything, so what is our result? So the DPI means to up to the I day, how much money we consume. It's not the ith day, it is all the days before and including the I. So means here is also 2. So if it is not inside the days array, so in the second day, so we're gonna just use the DPI should equal to DPI minus 1. So this is the transformation function. So it should be DPI minus 1. Yeah. And for other days, for example, day 3 is not inside the days array. So the index 3 is not inside. So we just give a 2. Yeah, because it should be equals to DPI minus 1. So what about day 4? So day 4 is inside, right? Because this index means the days, and here the day 4 is inside. If it is inside, so we're gonna check how much money we will consume. Yeah, so we're gonna choose the minimum of 1-day ticket, 7-day ticket, or the 1 month ticket. Yeah, so here we only have like 2 days, 1 and 4. So we're gonna choose to buy a 1-day ticket. So here that is why it's 4. Yeah, but here comes the problem: how this value is calculated. Yeah, how this 4 is calculated. How should you know the 1-day ticket is the best? So for here, it is just another situation. So if the days is inside the days array, if this index I here for the DP array index I is inside the days array, so what are we gonna choose? Yeah, we're gonna choose the minimum of. So inside it should be the maximum of 0. So I just have a boundary because I'm not sure if I use a 30 days, it will be I minus 30. It means the 30 days before it will be outside of the boundary. So I will give a max of I with I minus 1. So this is for the DP. Yeah, because it's a 1D array. So inside it is max. And here it also DP inside it is a max of 0 to minus 7. So this minus 7 means we choose the weekly ticket. And also we can choose another way. It is a max of 0 to I minus 30. It means we choose a monthly ticket. Yeah. But what if we choose the ticket, we should plus the value. So here it is actually the DP. Yeah, because we need to find the index. If I minus 7, it means the 7 days before. We should plus the value. So here it is costs 1 because cost 1 is a weekly ticket. And here should plus the cost 2 because cost 2 is the monthly ticket. Yeah, as you can see. And here If you choose to buy a one-day ticket, so it inside it should be costs 0. Yeah. Let me give you another example to explain it more clearly. So for example, we're gonna choose let me choose this day. Maybe we choose day 8. So for the day 8, we're gonna find the index 8. It is here. So 8 is inside our days array. So it means we're gonna choose this formula. So for this formula, we're gonna choose 3 combinations. So for 8, if we choose the one-day ticket, it means the cost 0, it is 2. I need 2 plus the day before. Just I minus 1. It means the day before it. So the day before it, it is 7. So 7 plus 2, so it is 9. It means we choose a one-day ticket. This is 9. Why? Because if we choose a one-day ticket, we consume this day here. It is 2. But from 1 to 7, we can choose a weekly ticket. It is Y. Or we can choose a weekly ticket plus a one-day ticket. So this means this will be I minus 7. So I is 8. 8 minus 7, it is 1. So from index from 1 maximum of 0 at 1, it should be 1. So this is DP1. DP1 is 2, right? 2 plus a weekly ticket, it is 7. So it is also 9. And then we can also choose a monthly ticket. So for the monthly ticket, we're gonna consume 15. So for the 15, so here is 15 and here is DP0 because 15 minus 30, it is minus 15 with a boundary of 0. So it is 0. Inside 0, it is 0. But it means here we're gonna consume 15. So the minimum of 9, 9, and 15. So it will be 9. So here will be 9. If you understand this example, basically you understand the whole problem. It's a 1D array DP problem, and it's similar to Coites 1. Now let me go to the code editor to finish the coding. Actually, coding is exactly the same as my explanation. It means the coding is not so difficult. So 0 should times the maximum of days plus 1. If the maximum of days is 20 inside the array, it will be 21 for the DP array. Let me prepare a parenthesis for this maximum of days plus 1. Now we are going to check. Let me prepare the days for a set of days. Because later on we are going to check if this index is inside this or not. So it will be the set of days. Now I'm going to loop through the DP array. So for I in range, for 0, I'm not going to consider because it is just easy for calculation. So the index I means the ith day. So if index equal to 1, it means the first day, day 1, to the length of DP array. Now I'm going to check 2 conditions. So if this index I is in my days. This index I actually for the DP array, it means the ith day. So it's exactly the same. That is why I prepare 0. For one thing, it is easy for calculation. And for another thing, we are making the index I exactly as the days inside the days array. So this one day is this index I is exactly the same. So if this I means it's inside, for example, this I is 1 inside the days array. So we're gonna do something. If it is not inside, let me first prepare the not inside. If I, because that is easier. If it is not inside, so for the DPI, that's equal to DPI minus 1. It means we didn't do anything. We just take the previous value, previous state of the DP array. If it is inside, it means that at least we will consume some money. So the DPI should equal to the minimum because we are going to calculate the minimum. So for the DP array, it would be max of 0 with a boundary of I minus 1. This means we're gonna choose the one-day ticket. If we choose one-day ticket, it means we're gonna plus a cost of 0. Or we can, let me put it here, make it more clear. or we can choose another. Let me copy the code here, or we can choose a 7-day ticket. So for the 7-day ticket, basically it's the same, just to change it to I minus 7, and the cost should be cost 1, because this cost is for the 7 days ticket. And then we can also choose another way. It will be a 30 days ticket, so it will be 30, and here will be 2. So this DPI just means if we choose at the DPI, we need to check the minimum of all those combinations because we are not sure which one is minimum. For example, yeah, if this is I minus 7, it means we can choose current day, we can consume a ticket of like cost I of $7. Yeah, but this is $7. Actually, it means from the current index to 7 days before. Yeah. So as my explanation, if we choose the weekly ticket, so it means from here to 7 days before. Yeah. So here it means this is a 2, this is a 1-day ticket, and 7 days before it is our cost 1, it is a 7. Yeah. And finally, we just need to return the DP minus 1. Yeah, because the DP minus 1, it is for the last day. Actually, the cost is accumulated for the DPI. Now let me run it to check if it works. Yeah, as you can see, it works. Now let me submit it to check if it can pass for all the testing cases. And by the way, the time complexity is just ON, because for the tickets array, for the cost array, it is just 3. It didn't consume any time. And for the range, it is the length of the DP array. So for the days, maximum it can be 365. So the time complexity is just ON. Because here we give a set, so we're gonna check inside or not. Here is just O1. So this is why it is a ON time complexity for this problem. As you can see, it passed and it's pretty fast. Thank you for watching. If you think this is helpful, please like and subscribe. I will prepare more Leetcode problems like this. See you next time.